Today we're diving into the power supply of the TEAC 80-8. After years of service, these electrolytics have had it, and tired caps mean dangerous ripple, instability, noise, and strange odors. We'll desolder, refit, and recap the entire board, carefully modernizing it and without changing any of its character. Along the way, I'll show you how to handle lifted pads, multi-lug cans, and a few creative tricks for making modern components fit vintage footprints. Now, this is going to take some finessing because in the process of desoldering this right here, the soldering tool took part of the pad with it. So this lead is going to have to be bent over and actually soldered to this point here because there's no solder pad left. Just kind of curious to just see how bad this one is. I'll be checking them all eventually, but 105. Technically, it's a good cap, but good doesn't feed the bulldog. It's old. Yeah, like I've got room to talk. $100 at 25, which I'm going to replace with $100 at 35. $100 at 35, which you replaced with $100 at 35. $47 mic at 25, which I believe I'm replacing with a 50, and it's still half the size. I gotta tell you, there must not have been any solder shortage back in the day. 100 at 16. The only 100 I have here is 35, so I'll use that one. $47 at 50. So these three capacitors are remaining. What I've got is the 4700 at 63, which, check this out. This one right here is going to replace this one. It's about half the size. About the same diameter, but half the size. This one has got lugs on it that I'm going to have to nibble down in order to get just a pin left connected in order to be able to fit it through the circuit board. I'm going to save that one for last. Let's check out these other two. Well, I can already tell by looking at it. My desoldering tool is not going to fit on those leads to get those out of there. This is going to have to be a wicking job. And I'll just point out, that little arc right there is not my doing. Although for this top capacitor here, there are in fact 3 solder lugs and 3 leads that come through the board, but this solder lead doesn't actually have a foil run associated to it. So that is just a hold down. It's just to hold the capacitor in place, and I'm fairly certain that these are the 2 leads. Same goes for this one here. These are actually going to be the electrical contacts, and that's just to help hold it down. These 3 here, probably because that capacitor is so large that they're using these 3 to hold it down, and these are going to be the contacts. Now I'm curious, because this capacitor has 3 leads on it, this one actually has a black paint on it, which turns out to be the negative. I'm just curious if internally these 2 leads are tied together. Now, of course, one of them wasn't really connected to anything. It was just soldered down in order to hold it in place. It's not reading any measure of capacitance, but it does read a resistance value. And it's increasing as though it were a capacitor. I'm up to 29 meg now, 30 meg. Strange. It's as if there's a capacitor there, but the labeling says it's blank. It says that it's 2000 microfarad, yet it's supposed to be 2200. But a DMM contemporary DMMs, they're okay to measure capacitance, but don't bank on it. All right, so let's take a second away from the bench and talk about what's really going on inside these little cans, some bigger than others. Every electrolytic capacitor has a paper and foil sandwich soaked in electrolyte. That fluid lets it store electrons and thus smooth out the DC voltage. But over 40 plus years, that fluid dries out. The internal resistance rises, kind of like somebody else I know. Instead of filtering ripple, it causes more. That's why vintage gear develops hum and loses headroom long before it ever dies completely. When I replace them, I always go a step higher in voltage and temperature rating, like bumping a 25 volt capacitor to a 35, or going from 85 degrees centigrade to 105 degrees centigrade. It's cheap insurance. And if a pad lifts while you're working, don't sweat it. Just trace where that lead went and run a short jumper wire. Keep it short, keep it neat, and you'll have a stronger connection than the factory ever did. Because this is your machine, not just the product of mass production. Modern parts are smaller, cleaner, and tougher. The trick is learning how to make them fit electrically and physically, and without changing what the circuit is for. That's the art of restoration. This particular capacitor, although it has all of these leads on the bottom, only 2 of which are actually in use, because they give you a pictorial diagram here of the layout of the pins, but ultimately only the one marked black being negative, and then C, which is 4700 at 63 volts, which is actually going to be right up here at the top. That picture is a little bit misleading because it shows 5 equal circles inside of a circle, and that's not the way this is laid out. And looking at the circuit board, the positive lead is actually directly 180 degrees out from the negative lead. In order to duplicate these 2 leads right here with this capacitor here, what I'm going to end up having to do is some creative fabrication, we'll call it. And what I'm going to end up doing is just basically soldering some leads onto these leads here. I'm going to lay these down and then solder on a lead extension, and then fold this one down and solder on a lead extension. But I want to use solid wire. Now I'll just use this capacitor as a guide for where to bend the leads for the new capacitor. So now I get to test how effective my repairs have been. And what I'm going to do is I've got the bench supply, but I've got the variac actually turned way down. So I'm going to go ahead and apply power to that and just gradually raise the voltage, monitoring the current, make sure that nothing is going to be drawing excessive current. And at some point we'll probably see some illumination. Yep, we've got illumination on that bulb right there. Okay, I'm at 80 volts, 105, 110, and 115. According to this, it's drawing about 200 milliamps. No smoke, that's a good thing. So the power supply, the motor control board, is all recapped. The RP boards are recapped. I haven't changed out the capacitors for the real motors yet because I only have one. I've got another one that's on the order and they're working currently. So I'm just going to leave well enough alone for now. I'm going to move forward on some of the other stuff that has to get done. No smoke and only one spark means I've earned a much needed refill. The power supply capacitors are done, the motor run caps are next, and reconfiguring the chassis to accommodate them gets interesting. Restoring these machines is part science, part art. Each capacitor swap brings us this closer to auditioning this deck in all its glory. Coming up next, cleaning the heads and tape path on the TEAC 80-8. We'll show you some of the remnants of some rather ugly Ampex grade sticky shed. Thanks so much for watching, and we'll see you soon.